Welcome to Talkin Science. I'm Matt Miller at Trekzone HQ. Today, a faint detection at the Ligo and Virgo gravitational wave detectors points to the possible formation of an intermediate mass black hole. Meanwhile, scientists studying deep sea samples find possible evidence of supernova remnants here on Earth. And the moon's getting rusty. Earth is probably to blame. Those stories, plus the headlines on today's show. It's Wednesday, September 9, 2020.
With the latest science and space news 5 days a week across Apple Podcasts, Spotify, Google Podcasts and YouTube. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
Brad, welcome back to Talkin Science, my friend. Another week.
Another warmer week, which is always nice here in Canberra.
It is getting warmer, so it must be approaching the high single digits for you now.
No, we had like 20 yesterday.
Whoa, heat wave.
I know, it's a bit out there. I mean, we're going to go back to like 14, but still, we're making progress.
It's 9.7 with a feels like temperature of 9.2, so it's positively freezing up here.
Exactly. You got to turn on the heater.
Exactly. It's all right. I've got a soaker as my hot water bottle at the moment, so that's we're all good. So I'm well positioned to tell everyone that you're on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook, and of course I'm on Twitter at Miramat86 and Trekzone all over social media. Just search for Trekzone. Brad, let's kick off the show.
Talking Science headlines.
And Brad, first up in our headlines, SpaceX is achieving the speeds that Australia's Liberal Party thinks is the theoretical maximum.
Yeah, look, Starlink, as we talked about a couple of months ago, was entering beta testing in northern Canada, northern Europe, those sorts of places. And the reports are they're getting 100 megabits per second, which is not only impressive for this early in the stage, but as you said, shamefully dismisses the ability of the NBN here in Australia. So it's kind of a 2-for-1 punch here. Not only are their capabilities, but it just shows what this technology promises to hold and make things obsolete in the future.
Absolutely. And they're also getting gigabit speeds, satellite to satellite, with their optical laser technologies, which is the critical component to making this whole constellation of satellites work and having handoffs as the satellites pass overhead.
That's right. Yeah, you don't want latency between satellites, just as if you're driving around and using mobile phones and the handoffs between towers. You want it to be pretty much seamless, and that's seemingly again what they're getting for this. So obviously more testing to do, but good progress so far.
Absolutely. Meanwhile, in China, the Chinese Space Agency has landed a reusable spacecraft, a mysterious reusable spacecraft, after spending a couple of days in space.
I think people say it's serious because it wasn't exactly clear what they were doing. And unlike US and even Russia, there's not a clear delineation between civilian space and military space. But obviously a big success for China in the sense that most of these reusable craft so far, either rocket boosters or planes, whatever it is, have been American made. So a big step in China being able to do it, even though it's just a couple days, it's still a couple days. And this is kind of similar. It looks like people are wondering in vain, at least style and potentially operation, to the X-37B, which is the U.S. Air Force's robotic reusable space plane drone thing. So we'll see what happens with it in the future, but a big success for them nonetheless.
The Chinese space program is an interesting case study, really. It's compressing down, say, America's and Russia's space programs over the last 50, 60 years. They're making these discoveries on their own, but they're just running through the paces, really, and now they're sort of up to the third decade of US design in reusable technology.
Yeah, they're playing catch-up, but as you said, they're doing it quite fast and quite successfully, too, which is always something you want to have hand in hand. So definitely trying to emerge as equal footing in terms of space capability as, say, the US and Russia.
Now, over in Utah, in the mainland United States, a 2-minute test has marked some pretty significant milestones for the American Space Agency. Their SLS booster has been test fired successfully.
Yeah, they did the static fire testing, where essentially you bolt this giant rocket to the ground and hopefully it works. And this is kind of that critical stage before you actually start doing more complex things. Does just the rocket turn on burn and operate the way you intend it to. And it's great. It looked so far, at least from early reports and based on the video and all those sorts of things, very successful. So it's a great progress for the Space Launch System.
Now, the booster was supposed to fire 3.6 million pounds of thrust upon ignition and remain active for 122 seconds. We're going to know the exact performance metrics in a little bit of time while the scientists study the data. But that's about what it needs to do to get the Artemis missions into orbit.
That's right. These are the first stage as it was. So this is what they're trying to test to get into that initial 2-minute burn and the right amount of thrust. So as you said, waiting for the data really to come back, but it didn't explode, it didn't break, it didn't fizzle out, it didn't do anything seriously wrong, which is at least a solid step.
Talking Science, Stories of the Week.
Two massive black holes have joined together. They've realized that they're better together.
A big area and a big thing that we've talked about in the past are these gravitational waves, these two black holes that collide and merge. It's an interesting phenomenon. It's something that's been happening since the first discovery of it back in 2015 with LIGO. And now that Virgo and now Conga, other detectors are coming online to detect these things. The ability to detect black hole mergers and the gravitational waves they produce. We're able to see further black holes or fainter signals. And in this case, I think the most exciting thing are the two black holes involved in this gravitational wave, 190521, and the result of it, where it was a black hole that was about 85 times the mass of our sun, and another black hole smaller than that, around 66 times the mass of our sun, merging or colliding together to form one about 142 times the mass of our sun.
There's some incredible scale involved there. And I know that I say that every time that we talk about these galactic events, but it is still just, for me, with a non-astronomical background, to imagine these things. The sun's pretty big. To times that by 142, to have the result of this little collision is just incredible.
Yeah, I mean, if you think about it, right, we could put 1 million Earths inside the sun, and now you're talking about something 66 and 85 times more massive, or resulting in something 142 times heavier than the sun. So 142 times 1 million Earths. But then this is the black hole. So you're taking something that's gone from something where you can fit 1 million Earths inside the sun and bigger than that, squishing it into something the size of a city. These are pretty remarkable densities and masses. And so it's definitely a cool discovery of LIGO.
And the interesting thing here as well is that they're not quite sure, astronomers and scientists aren't quite sure how they get so supermassive. One theory is that they're merging over and over, spinning past each other and just trading off all of their energy and all of their material till they become this super dense object.
Well, and this has been one of the thoughts that, black holes just keep merging and merging until they form the intermediate mass one. So intermediate mass black holes weigh between 100 and 100,000 times the mass of our sun. So at 142 would be entering this stage, growing up to the supermassive ones. And then when we look at the culprits here, especially the 85 one, we think that up to about 65 times the mass of our sun, when a big star explodes, that's when it creates what we call a stellar mass black hole. So inside the star, the inside of the star essentially squeezed together, the guts are squeezed together and compressed as it starts to implode. And in that compression, it squeezes most of the mass of the star into a small area, this black hole. But we thought at about 65 times and up to 130, there's a different mechanism of explosion. So instead of kind of the insides being squeezed, what we call core collapse, there's a triggering that goes on in the inside of the star. We call this pair instability, but ultimately it's like a chain reaction inside the star, causing all of the star to ignite and explode. So we thought that the thing 65 to 130 didn't explode in the way that it would create a black hole. So where did this 85 one come from? And people think, as you were saying, maybe this already was a result of two smaller ones. And we have seen things on the scale of 30 and 40 times the mass of our sun merging to form the 70 to 80 time mass ones. So maybe this 85 one was the result of two previous black holes colliding and merging. So this was actually 3 black holes at over time coming together to form it. So it's really starting to push and expand our knowledge of how black holes grow.
The one thing we can probably say with certainty is that you wouldn't want to be around this parsec of space while all this is going on.
No, there's definitely a lot of energy happening here. We're glad the Earth is where it is.
Now, because of the nature of this detection being quite small, Ligo and Virgo astronomers are considering that it may not have been a black hole merger.
Yes, so this was on the weaker end of it. So, there's been some analysis about whether it's been a noise event, because there are things that cause noise. There are even terrestrial events that can kind of simulate gravitational waves, so they're just natural phenomenon. Or, could it have been something else from this? Look, a lot of data still points to this being a real event, but this is definitely on the boundary of distance and therefore signal strength that it can pick up.
5.3 billion parsecs away, so it's the furthest merger that LIGO and Virgo have ever found, which is very cool.
By having more of the detectors, the triangulation or location is better of it, and then also the sensitivity of detecting these things is easier and better. So, these discoveries are only going to increase. The field is just going to get bigger and bigger, and we're going to be probing more extremes of the universe, which is cool.
Brad, next up this week, we found a supernova or supernovae under the sea. That's an odd place for them.
Something like that. And it's really because they're finding the debris or the leftover bits of a supernova. So we know when supernovas explode, they essentially blow the remaining bits of a star. And so this energy rips apart the star, it blows apart the protons and neutrons and all that sort of stuff. And in some of these cases, it turns the elements into what we call different species. So you can create different types of different elements. And it's kind of this weird thing to think about that, we're used to just having hydrogen and helium and all this other stuff. There are different types of hydrogen and helium. In this case, there's different types of iron. And in one in particular, what we call iron 60. So normally iron is 56, so 28 protons and neutrons. Iron 60, which has a couple of extra neutrons in it, which we think is only created when stars explode by getting this essentially extra stuff in it, was found embedded in the seas at different locations in the ocean. And the conclusion is only a supernova could have created this, not anything naturally here on Earth or human made.
And the current thinking is that the only way for this iron 60 to be in the sediments of the deep sea here on Earth is for Earth to be traveling through a cloud of radioactive dust from that supernova.
Yeah, I mean, when stars explode, they explode. So, just think of any other explosion. It throws debris, and in this case, the debris is the leftover bits of the star and the elements and the radioactive bits that it creates. And so if the Earth travels through this, a bit of this radioactive debris can rain down on the Earth. And I think, what's exciting, at least in this case, is they found one that appears to be around 2.6 million years ago. So just like if you think about carbon dating and looking at half-lives, you can use radioactive dating and the decay, the half-lives of this iron 60 to get an estimate of how old it is. And so there's stuff that is definitely pointing to around 2.6 and maybe even 6 million years ago. So maybe this actually happened twice in the history of Earth. And, 2.6 to 6 million years seems relatively short. It kind of is. In a galaxy like the Milky Way, we expect a star to explode every 100 years. So there's actually lots of potential stars that could have exploded in that time frame. And if you get a few that are relatively nearby or in different pockets of the Milky Way as the sun and the solar system move around, the Earth can travel through this.
And when we're talking about radioactivity, we're not talking about anything necessarily lethal to human life. Otherwise, we probably wouldn't be here. But it is just enough to be detecting it and putting it onto a scale and analysing it.
Yeah, and these things affect a little bit of stuff. And it's also looking at just how likely are these things, because there's a belief that one of the previous mass extinction events, so 452 million years ago, there was another mass extinction event. Now, this wasn't, asteroids like the dinosaurs got. They got what they deserved. No, there's been questions about what led to this previous mass extinction event. And one of the theories is that there was a really close supernova that did produce a lot of radiation that rained down on the Earth and wiped out a large fraction of the life at the time, leading to this mass extinction event. So by finding these other clues that not only does this stuff happen, but the Earth can potentially travel through it at different times, maybe that gives support more to this theory and potential evidence.
Now, last year, researchers in Antarctica discovered some similar stardust, also containing iron-60. So it's all sort of leading into this, furthering this understanding of the fact that the solar system travels in the galaxy, and it's traveling through some pretty funky stuff.
That's right. And they just looked at, ice cores in Antarctica. You look at the isolated bits and on the Earth, which obviously haven't been changed or moved around. That's why the ocean's great. That's why Antarctica's great. And so there's clearly stuff that happens, and it's not unexpected. And again, 2 to 6 million years, a lot of things change. So it's not something that we have to be worried about. In fact, there's very few stars that are even in the realm of monitoring that are going to explode near us that produce it. So it's not like anything that we really have to worry about for human civilization. We really have to worry about us more doing this ourselves, to be honest. So it's not like a natural thing that happens that often, but in the history of a planet, it's a real thing that happens. And it's always important to think about then when we talk about planets around other stars and the life they may support and all that sort of stuff. These are real things that we have to think about in terms of how life may evolve and be supported.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
Well, Brad, when I read this last headline, I thought, I immediately went to what have humans done to the moon? But it turns out that it's actually Earth, the planet, might be at fault for this one. The moon is turning rusty.
Rust is essentially iron oxide, right? It's oxygen binding to iron, and that's causing a decay or the rusting of the iron. And it's usually when iron is exposed to a mixture of water and oxygen, as we know here on Earth. And there's lots of evidence that this thing happens naturally. When you see red stuff, Mars even, the Red Desert, the Great Canyon, all these sorts of things, there's a bit of element of iron oxide in this. What's been measured, and this is from the Lunar Reconnaissance Orbiter, which has been going around the moon for quite a while, and also India's Chandrayaan-1 mission, which is one of the first big missions to prove that there was ice on the moon, that by measuring the amount of iron oxide on the moon, it's increasing. So, since 2008 or whatever, I think when they started to look at it, iron oxide has been slightly increasing on the moon, and therefore the moon has been getting rustier over time.
And one theory for the cause on this is Earth's magnetotail, which is the part of our magnetosphere, which is extending all the way to the moon. It's shielding our little lunar from the renewing hydrogen that solar winds produce.
I think the best way to think about it is almost like we're keeping it slightly damp, right? It's not drying out by natural processes in space, as he said, the solar wind. And we do know the Earth's magnetic bubble, the magnetic field is quite strong. It extends for quite a while. Maybe we're abnormally or extra blocking these things, and therefore it's creating a little bit of extra havoc. That's obviously just kind of one of the theories or the ideas to this problem. It's something that really needs to be better studied. But it's definitely kind of just one of these interesting things when we think about the Earth-Moon interaction. We just think of tides, but there's so many other things that go on between the two, both how the moon affects the Earth and how the Earth affects the moon.
Absolutely. And it seems to be isolated to the polar regions.
Yeah, the poles are where there's a lot of ice contained, especially the South Pole is quite rich in ice. So there's clearly something going on with how the ice is distributed on the moon and what this leads to, this iron oxidation, this rusting. So obviously, it's important to understand not only just what's causing this, but as we talk about sending humans back to the moon and the Artemis mission and stuff that we were just talking about, those missions are going to places that have ice because that ice is critical to supporting life, both for water, but also using it for fuel sources and breathing sources. So clearly, there's some important understandings in how this effect is. And what it means for potential future space travel.
Now, the discovery of this, I think, is incredible. We don't have anyone on the moon, obviously. So the Moon Mineralogy Mapper detected spectra, which are the wavelengths of light reflecting off various surfaces. That then being analysed comes up with iron, and it's in a very similar spectral signature as what's currently found on Earth, which leads to the theory that that it's Earth that's causing these problems for the moon.
Yeah, you can. So each element has its own signature of light. It's like a fingerprint. Every element and every combination of not just elements, but molecules, in this case, iron oxide, water, all those sorts of things, carbon dioxide, they have very unique signatures. And we can look for those signatures to their color and identify what it is. And in this case here, we were able to see the exact iron oxide signature, so the exact composition of iron and oxygen ratio, what it looks like here on Earth, and seeing that, hey, it looks similar to the one on the moon, trying to use this as a culprit, as a fingerprint matching, for lack of a better phrase. And so it really just shows when we send these instruments and probes, and not just to the moon, but Mars. We were talking about this with all the different instruments going to Mars, doing different types of measurements around these objects just gives you a wealth of data, sometimes understandings of things that you thought you knew, but you wanted to understand better, or just complete surprises, things sometimes out of left field that you never even thought you would be studying, that the moon is rusting, but now you are.
And this could lead to discoveries of a greater variety of minerals on the moon than previously thought could exist there, obviously with the discovery of water as well. It's all sort of leading to maybe the moon isn't quite made of cheese anymore.
The moon gets its rap for being boring and dry and all that sort of stuff, but maybe there's a bit more to it.
Fantastic, Brad. Well, in the years to come, I'm sure we will know more, especially if those SLS boosters work and Artemis can get to the moon and we can get digging once again.
And this will happen as people start going on the ground and more samples are taken, and even some of the return missions being planned. We'll get better clues as to what's going on. It's exciting to learn more about our important moon.
We're looking forward to that. Looking forward to next week's Talkin' Science when we get to catch up with you again. For now, though, Brad, it's fun to pick apart the stories of the week. Thanks for zooming in.
Take care.